an angle of 45 degrees, and then she makes a turn of 60 degrees. I want to know what are the components, or the little shadows onto the x and y axes for these two vectors. Is anyone stuck and want me to start drawing some hints? Yeah, draw some hints. Okay, cool. I'm gonna start. So if you're doing it, just ignore me. If you're kind of stuck, I'll talk about it. So I would start by looking at vector A, because it's alphabetically first. And then I want to figure out what are the shadows. So I can either pick, I can pick two triangles, right? And both are fine. I could either make this my triangle, or this my triangle. This is my triangle. It'll be the same thing. So I'm just going to redraw A over here. Here's A. And I know that this angle is 45 degrees. So if I were to make this my triangle, right, this is my along the x, along the y, or I could make this my triangle, and you can use that inner angle theorem, right? So this is also a 45-degree angle. Maybe you didn't see that, so you just go with the upper triangle. So I have a 45, 90, this is actually a 45, right? You have to have 180 in the triangle. So this is the triangle I'm working with. I know that this side is 25 kilometers. And then half of the question is, what is this side? And what is this side? So you're going to want to use trig. So I wrote down those kind of like cheater equations, that final result. If you were to just do, if you were to look at this side, I would use cosine because it's adjacent. So I would do cosine of 45 equals the adjacent over the hypotenuse. You can multiply this over here, which is what this expression is. And I know that cosine of 45 degrees is cosine of pi over 2, or sorry, pi over 4, which is 1 over root 2. Same sort of thing for the y. And then you repeat this for the b.
Cosine of 45 is pi over 2.
Cosine of 45 equals the cosine of pi over 2.
Oh.
This is radians, right? Is equal to 1 over root 2.
Oh.
So it is, on your unit circle, this guy.
Can we just use like the component, like AX equals A cosine theta?
This is the kind of, so that expression
Yeah.
comes from this.
Yeah.
So if you forget what the expression is, no big deal, as long as you know SOHCAHTOA, right?
Yeah.
You could figure it out. So in the heat of the moment, and you don't know what the equation is, just think back to cosine. And then you just multiply by that hypotenuse. Any answers yet? I forget what the answer is, but probably. I have faith in you.
I got AX.
You got AX?
Yeah.
What'd you get AX to be?
Well, I got 25 over square root of 2, but up there it's 17.7.
Okay, good. So then that eliminates two of the problems, two of the answers, right?
Yeah.
Good. That's the thing with multiple choice, you don't necessarily have to solve the whole thing. So, did anyone get a y, the y component of a?
You got 25, 7.5.
Okay, so that'd be 25 divided by square root of 2. So 25 over square root of 2 is 1.41, I think. So it's somewhere between 1 and 2, right? So it's got to be somewhere between 25 and 12.5.
It's 17.7 for AY too.
Okay, and that should make sense, right? Because look at this. We have a times 1 over root 2 and a times 1 over root 2. They should be the same. And that also makes sense because we have a 45 degree triangle. It's an isosceles triangle. These two angles are the same. So that makes sense. We should have the x component and the y component that match. All right, so we've kind of at least, oh, I must have messed this up and didn't fix it. Okay, so I will make sure that it is fixed on the thing. But the correct answer is the correct answer up there. So just be aware of your positive and negatives. For this vector, you're going in the positive x, negative y. Okay? And you could do, in order to get the answer for this one, you didn't have to do the b, but you could to kind of double check your technique. All right, so we'll talk a little bit about vector arithmetic, and you'll be seeing more of this tomorrow in your lab. But so in order to add two vectors, A and B, they have to have the same units. So you can't add inches to centimeters, right? Just like you couldn't do that for scalars, right? You couldn't do go 5 meters north and then 36 inches west and then tell me what that distance is, without converting units. So in order to add vectors, they have to have, the magnitude has to have the same units to it. And then what you do to make what's the resultant, which would be C. So if we're adding A and B, graphically you attach them tip to tail. So you attach, A plus B, you attach it tip to tail, right? So you do one, attach the next one, and then the resultant is connected tail to tail, tip to tip. So graphically, that's what this looks like. And keep in mind that a vector is defined by its length and its direction. But it's not fixed in one spot, right? So if I were to take this B vector, I could slide it, and as long as I don't twist it to change the direction or stretch it or squish it to change the length, it's still the same vector. So you could start off with, A and B both at the origin, and then when you wanted to add them, you just slide it without twisting it and without stretching it or squishing it so that it lines up tail to tip. And then you have the resultant, which is tail to tail, tip to tip. Right? So adding, you do tip to tail to add them together. The resultant, your sum, is tail to tail, tip to tip. And you can imagine a couple of different ways of adding these together. You could either do A plus B, or you could do B plus A. It doesn't matter, you'll get to the same sum at the end. And then when you think about subtraction, and you've probably seen this in your math classes with scalars, right? Subtraction is the addition of a negative number, right? So what negative would do is just flip the direction of that second vector. And sometimes it is easiest, if you want to find out what the resultant is, it's oftentimes the easiest and fastest to break both vectors into components, add the components, and then figure out what that final magnitude is. You follow? So what you could do is you have A plus B. You break A into its x and y. You break B into its x and y. You combine the x's, you combine the y's, and then you just have this new triangle, and you can do trig to find whatever you need to find. Whether it's what direction are you, is your final, position relative to the first one, something like that. So this is a very nice way to easily solve for what that resultant vector is. I think I'm going to skip this second example because we're a little short on time, but you can play along at home. I will post these, and let me know if you have any questions on them. And I mentioned that what a negative sign does to a vector is it just flips the direction. So originally we had A plus B, and we attached it tip to tail, right? Resultant is tail to tail, tip to tip. Now when you're thinking about subtraction, you could just add negative B. What negative does is it doesn't change the length, and it doesn't really spin it or twist it at all. It just flips which one's the tail and which one's the tip. So then when you go to add it, anytime you add, it's tip to tail, right? And then the resultant is tail to tail, tip to tip. So you make a negative, and then you just do addition, which is connecting it tip to tail. The resultant is tail to tail, tip to tip. So here is an example that was on the last slide, where we're just subtracting, A minus B. So it's really A plus negative B. You could break these in order to find the components of D, the X and Y components. You could find the components of A, the components of B, and add those together, and you will find your components of D.